This video includes the second short example for tangents and normals of plane curves. Welcome to differential calculus. There is a pattern in solving for the equations of the tangent and normal lines of plane curves. The first step is to look for the slope of the function by taking its derivative. With a provided point, you surely will be able to find a numerical value for the slope. This parameter is used through different line forms, depending on what complementary data is given. The first format for the line is a slope-intercept form, which is y as equated to mx plus b. This is used when y-intercept is given along with the function. The second line format is the point-slope form, which is y less y1 as equal to the slope m times x less x1. This is used when the complementary data given are coordinates of a point. Both line formats result to the tangent line of the plane curve, so next is to solve for the normal line. With the same procedure, one only needs to change m tangent into the normal slope, which is basically just the negative reciprocal of the tangent slope. Plug these into the line format of your choice and have the normal line function. Take note that we are to look for the slope using derivatives and partner it with those line formats which have slope too. This is the main reason why slope-intercept and point-slope formats are usually incorporated. The second sample problem is y is equal to x squared minus 2x, and the tangent and normal lines involve the intersection with the line y equal to 3. Having just a partial coordinate, we still would employ point-slope form. However, we have to identify x. From the function y is equal to x squared minus 2x, plug in y as 3. In order to find the values of x, transfer all terms into one side, making x squared minus 2x less 3 as equal to 0. By factoring, we get two pairs of binomials, x plus 1 and x less 3. Thus, the first value of x is negative 1, and the second is positive 3. Next is to determine the slopes. Take note that there are 2 points, which means we are to look for 2 slopes, but the differentiation leads to one general slope equation. M or y prime is the derivative of x squared minus 2x. With separable terms, we take the derivative of x squared with negative 2 times the derivative of x. Dx over dx is equal to 1, so m is then taken as 2x times the derivative of x by chain rule minus 2. So the slope formula for tangent is 2x minus 2. Now customize the slopes for each point. The first point is at negative 1, 3. Plug x of negative 1 into m of 2x minus 2, making it twice of negative 1 minus 2. This results to the first slope as negative 4. Also solve for the second slope using the second point of 3, 3. Substitute 3 for x, making twice of 3 minus 2, giving the second slope of 4. We can then solve for the equations of tangents using the point-slope form. For the first point, involving point negative 1 and 3, and slope of negative 4, the equation turns into y minus 3 as equated to negative 4 times x minus negative 1. This is simplified into y minus 3 as equal to negative 4x minus 4. Arrange terms and get 4x plus y as equal to negative 1. Next is the second point with coordinates 3, 3. Its slope is 4. Plug these values into the form and have y minus 3 as equal to 4 times the binomial of x minus 3. Simplifying terms make y minus 3 as equal to 4x less 12. Arrange them and get 4x minus y as equal to 9. Next is to look for the equations of normal lines, still using the point-slope form. Note that the slope used is that for normal line, and since what we have available are the tangent line slopes, use the relationship that the normal slope is just the negative reciprocal of the tangent slope. So for the first point, with coordinates of negative 1, 3, and tangent slope of negative 4, the equation then becomes y minus 3 as equal to negative 1 over negative 4 times x minus negative 1. The two negatives from the slope cancel out, then 4 is cross-multiplied into the other end, making the equation 4 of y minus 3 as equal to x plus 1. Distribute 4 among the terms and have 4y minus 12 as equal to x plus 1. Arrange the terms and get x minus 4y as equal to negative 13. For the second point with coordinates 3, 3 and tangent slope of 4, the equation then becomes y minus 3 as equal to negative 1/4 of x minus 3. Cross-multiply negative 4 to the other side and have negative 4 times the binomial of y minus 3 and equate this with x less 3. Distribute the constant to have negative 4y plus 12 as equal to x minus 3. Arrange terms to have the standard form of x plus 4y as equal to 15.